Daniel, how do we get electricity?
We can get it from a variety of places, renewable and non-renewable. Non-renewable energy resources are the most commonly used, such as coal and nuclear power plants.
Ooh, nuclear power plants. That sounds interesting. How does it work?
Luckily for you, I have the perfect diagram to demonstrate how a nuclear power plant works. You might want to sit down. Here we can clearly see all the components of the power plant. In essence, a nuclear reactor is a system where a controlled fission chain reaction occurs, releasing energy used to generate electricity. The nuclear fuel in the reactor vessel, where the fission chain reaction occurs, heats up the water in the steam generator. When active, the core reaches a temperature of 300 degrees Celsius and withstands a pressure similar to that 0.5 miles below the ocean, or 40,000 tons worth of force. This steam then flows through a turbine which powers a generator and creates electricity. The steam is then condensed and the water is reused in the generation process.
Oh, okay. That makes sense. But what about that fission stuff? What happens there?
The process that occurs in the nuclear reactor's core is known as induced fission. This is when slow thermal neutrons are fired at the uranium-235 fuel rods. Neutrons have no charge and thus cannot be accelerated using an electric field. We therefore give this neutron kinetic energy by heating it up, giving it enough energy to move, but also enough to move at a rate that is slow enough to be absorbed by the nucleus. The uranium-235 nucleus absorbs this neutron, forming uranium-236, a highly unstable isotope. This then splits, giving daughter nuclei, such as barium-141, krypton-92, and 3 neutrons. These 3 neutrons fire off into different directions, creating a chain reaction, repeating the process. However, these neutrons are emitted at high speeds, and thus need to be slowed down. To do this, we use a moderator, usually made of graphite.
Wait, so there's always more and more neutrons being emitted. What if we want to slow down the reaction?
That's why we have control rods. Usually made from boron, these rods are lowered and raised depending on how many neutrons they want to absorb, and by how much they want to slow down the reaction. This prevents a nuclear meltdown.
What's so bad about a nuclear meltdown?
A nuclear meltdown is when the core of the nuclear reactor overheats severely, which can happen if the rate of fission isn't controlled, and the core melts, releasing radioactive materials. Radiation that escapes can be both highly poisonous and ionizing, causing severe health effects.
Wait, you still haven't explained how fission creates energy.
But yeah, energy is released when fission occurs, since the bond energy is released. This is first noticed as kinetic energy in the products of the reaction. Since these particles undergo intense deceleration in the solid nuclear fuel, the kinetic energy turns into heat energy. A small amount of the mass of the nucleons is converted into energy needed to hold the nucleus together, called the nuclear binding energy. This is where the energy comes from, easy with the mc squared. This heat then boils water, creating steam, turning the turbine.
Oh, right. Cool.
Oh, and just in case you wanted to know a little bit more detail, the 2 most popular reactors are pressurized water reactors, or PWRs, and boiling water reactors, or BWRs. In a PWR, the nuclear reactor heats up a primary coolant loop of water, which then heats up the steam generator. In a BWR, the nuclear reactor directly heats up the water. The advantage of using a BWR is the increased efficiency of heat transfer, as energy isn't lost heating up 2 containments of water. However, the advantage of a PWR is that it's easier to maintain and identify leaks.
Radioactivity sounds all well and good, but are there any problems with it? Why don't politicians like it?
There are a few problems with nuclear power plants. These include high costs, the possibility of a reactor incident like that in Fukushima, the development of nuclear weapons, and the production of nuclear waste. However, some countries have developed nuclear reprocessing plants, such as that in Sellafield in the UK. Although this doesn't entirely eliminate the issue of waste, it has been able to prolong the life of the nuclear fuels. Reprocessing plants have progressed from extracting plutonium to produce nuclear weapons, to reprocessing uranium to be recycled as nuclear fuel.
So much. I am so wonderfully full of knowledge now.